All right, piecewise linear functions are functions that are composed of linear segments defined for specific intervals on the graph. So for example, these are piecewise functions here, and in this, let's look at the middle one. What this means is that we have the equation y is equal to x plus 5. But we only have this equation for when your x values are less than or equal to 3. And then we also have the equation y is equal to 2x minus 1. But we have this equation for only when x is greater than 3. So on the graph, you would have a straight line, something like this, but it stops at a certain value, at the value of 3. And then you would have another straight line that looks like this coming off of it in a different direction. That's a piecewise linear function. And what we're going to do today is we are going to evaluate some piecewise linear functions. So for this first one, we want f of 2. What that means is I'm going to be focusing on the f of x piecewise linear function. And I have an x value of 2. So first I look at my inequalities. Is 2 less than or equal to 0, or is 2 greater than 0? Well, 2 is greater than 0. So that means I'm going to use this bottom equation, which is the equation y is equal to 2. So what that means is that your y value is 2 when x is 2. Now, looking at the next one, f of negative 4, well, I want to use the f of x function again because I see the letter f, and negative 4 is my x value. So I'm going to first look at my inequalities. Is negative 4 less than or equal to 0, or is negative 4 greater than 0? Well, negative 4 is less than or equal to 0, so that means I'm going to use my top equation, which is the equation y is equal to 3. So that means your y value is 3 when x is negative 4. So next one, I have f of 0. That means I'm going to use the f of x function again because I see that letter f there. And my x value is 0. So look at your inequalities first. Is 0 less than or equal to 0, or is 0 greater than 0? Well, 0 is less than or equal to 0. So using the f of x function for the top equation, I have the equation y is equal to 3, which means that my y value is 3 when x is 0. I'm going to have you find your y value for when x is 1/2 for the f of x function. All right, well, you should get a y value of 2. Moving on to now g of x, because I see g of 7. What that means is I want to use my g of x function. 7 is my x value, so looking at my inequalities first, is 7 less than or equal to 3, or is 7 greater than 3? Well, 7 is greater than 3, so what that means is I want to use the bottom equation, which is y is equal to 2x minus 1. So what I'm going to do is I'm going to put 7 in for x in that bottom equation to find my y value. So I have a 2 times a 7 minus a 1, which is a 14 minus a 1, or a 13. So my y value is 13 when my x value is 7. Moving on to g of 0. So I'm going to use my g of x function again. My x value is 0. So looking at my inequalities, is 0 less than or equal to 3, or is 0 greater than 3? Well, 0 is less than or equal to 3, so that means I'm going to use my top equation, which is the equation y is equal to x plus 5. So what I do is I put 0 in for x in that top equation. So I have a 0 plus a 5, and then I simplify to find that y is a value of 5 when x is 0. So I'm going to have you now try the g of negative 1 and the g of 3 on your own by pausing the video. All right, here are your values for g of negative 1 and g of 3. moving on, we're now going to do the h of x function. And I want to do h of -4. And -4 is less than or equal to -2. So that means I'm going to use my top equation, which is y is equal to 1/2 x minus 4. So I'm going to put -4 in for x. And now simplify. A -4 times a 1/2 is a -2, and a -2 minus a 4 is a -6. I'm going to have you pause the video and try the next three on your own. All right, so you get -5, 5, and -9. Moving on to number 2. So now I just have one piecewise function, and I want to find f of 7. Well, 7 is greater than 4, so I'm going to put 7 in for the 3x minus 5. So I have a 21 minus a 5, which is a 16. Moving on to the next one, I have f of 4, and 4 is less than or equal to 4, so I'm going to put 4 in for the x squared. Notice how I'm putting it in parentheses as I do so. A 4 squared is a 16. Moving on to the next one, I have f of -3. Since -3 is less than or equal to 4, I'm going to put it into the x squared, which again, I'm going to put this in parentheses. A -3 squared is going to be a +9. All right, moving on to the next one. Yours should be on the same page. Mine is not, unfortunately. So I'm going to do f of 10. And so 10 is greater than 3. So I'm going to put 10 into the bottom equation, which is 6 minus a 2x. So 6 minus a 2 times a 10 is really a 6 minus a 20, which gives me a -14. Now doing f of 2. 2 is in between 1 and 3, so I have the equation y is equal to 3. So I don't need to put 2 into anything, I just wind up with y is 3 for that one. And then lastly, f of 0. 0 is less than 1. I'm going to put 0 into the equation of y is equal to -2 times the absolute value of x plus 1. So a -2 times the absolute value of a 0 plus a 1. The absolute value of 1 is 1, and then times -2 would give you -2. All right, that brings us to the end of this lesson, which is evaluating piecewise linear functions. In the next lesson, we are going to be graphing piecewise linear functions.